Hi folks, we are in section F3 at this point, looking at properties of perpendicular and angle bisectors. We talked earlier about what happens when we have a perpendicular bisector going through a segment, that all the points on that bisector are equidistant from the endpoints of the segment. What happens when we bisect an angle? Every point on that angle bisector is equidistant from the sides of the angles. And so now we're going to tie that together with something called a point of concurrency. That is a point where three or more lines intersect. And you'll see what I mean right here. Here's a triangle, ABC, and suppose you drew all three perpendicular bisectors to each of the sides. So XP would be perpendicular to AB, PZ perpendicular bisector of BC, PY perpendicular bisector of AC. All three of those perpendicular bisectors would intersect at point P. So that would be the point of concurrency of those perpendicular bisectors. And so what that really means is point P is equidistant from A, from B, and from C. So it's the same distance from A to B to C from point P. So theoretically, you could take a compass, put the center right there at P, and draw a circle that would touch A, B, and C. It's called circumscribing a circle around a triangle. And that point would be called a circumcenter. That circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. And if you look, here are three examples of those points of concurrency, those circumcenters. If you have an acute triangle, and we draw these red lines would represent the perpendicular bisectors of each side of the triangle. So here's a side of a triangle. This red line is the perpendicular bisector of it. This red line is the perpendicular bisector of this side. And this red line is the perpendicular bisector of this side. They all meet right there. And so that's the center of the circle that would touch at each point of the triangle. The circumcenter. We could circumscribe a circle around it. One thing that's interesting to note is when you have an acute triangle, that circumcenter is inside the triangle. If you have a right triangle, that circumcenter is actually right on the hypotenuse of the right triangle. And if you have an obtuse triangle, that circumcenter is outside of the triangle. So if you put the center of a circle here, the circle would come way out here, but it still would hit those 3 points. It would come way out there again. All right, and then we have the same kind of deal when we talk about the angle bisector. So we have the concurrency of the angle bisectors theorem, which basically says that the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So like we did before, if this is the angle bisector, then that means point P is equidistant from side AB and side AC. So these blue dotted lines would be congruent. The same thing would be true with this angle bisector and this angle bisector. So all 3 dotted lines would be congruent, meaning you could draw a circle inside the triangle. It would touch the sides of the triangle theoretically, and that's called the incenter, the point of concurrency of the angle bisectors of a line. So there's an example of that right here where we've drawn that circle on the inside. That's the incenter, so we could inscribe a circle inside a triangle. There's your notes for section F3. Let's take a look at a couple of examples next.